All right. Okay, so we're recording this, and this will be the November 5th lecture on math, character, and string classes. Okay, so first, let me talk a little bit about, so I've got during the quiz time in the first hour today, I got a number of comments, a number of questions that were related to this, and so I want to go ahead and address some of those here publicly because I couldn't keep up with all of them in the chats that you guys were starting. So let me see what was the main thing. Okay, so some of you are concerned about that you were receiving 0 points on some of, especially the text-based questions, such as explain why the identifiers were invalid, or even the coding question at the very end that you got 0 points. So let me give you an example here. Okay, so even just for the coding one, for example, I'm going to share with you here my my Java screen here. Okay, so imagine that I asked you to write a program, write a Java statements that what it would do is it would simply display on one line the word hello and then go down to the next line. All right, so how would you do that? Okay, so which one of these is correct? Is solution 1 correct? And I want you guys to go ahead and respond either in typing in the chat or for this lecture, or in you could even open up your microphone and go ahead and answer if you want to. Well, which one of these is correct? Would this solution 1 do it? Would this solution 2 do it? Would this solution 3 do it? Remember, we're displaying just the word hello, and then followed by a return to the next line. So just hello on one line and then follow to the next line. So which one of these would correctly do that? Okay. So go ahead and type your answers. Let's see. Right, so you guys are, most of you guys are seeing that all 3 of these solutions are what we would call correct, in the sense that they all do what I said I wanted the program to do. Now, we could probably see that solution 3 is not a good solution because it's hard to understand what it's trying to do. We're kind of, what's that all about? Solution 2 and so solution 2 uses this extra new line character in order to make the new line happen instead of just doing the print line command. So really, in terms of readability, solution 1 and solution 2 are about equal, really, if you think about it. Me personally, I would probably use solution 1 as my answer, right? Someone else might use solution 2. But the truth is that even solution 3, even though it's hard to understand, it still is technically correct, okay? And so that's why I can't have this system, like if I ask you to submit code as part of a quiz, or later if we end up having to do even like the midterm or final exam online as well, if I have you do something where you write code like that, I can't have the system automatically grade your code because there's so many different possible solutions. So I can't possibly make the system grade all of them, right? And same thing with the that question about explaining why the identifiers are invalid. The problem with that is, again, is different people have different ways of explaining things using different words. And so, so again, I can't possibly give all possible correct answers. Really, if you are in the mindset that there is only one correct answer to something, and that's how I'm going to be grading you, then I really need you to get out of that mindset. I really need you to be able to understand that there are many different possible correct solutions so to different types of problems. Okay. The other question, some of you, apparently you tried to submit it probably right at, my guess is that you tried to submit it right at 1020, and the system rejected it and it gave you an error. So I haven't made a decision what I'm going to do with that for right now. So what I want you to do is go ahead. The lecture at the end of the lecture at what is that, at 12:30? 12:30, there will be a quiz available for those students who are excused from attending this lecture. And so it's going to be open to all of you because I just made it open to the entire class. So what I want you to do is go ahead and take that quiz. And I'm not saying that I'm deciding to grade that quiz, but what I'm saying that if I do, that will be the quiz I will use. Okay, if you're in this issue of you tried to submit it, it was 1020, and so the system thought it's 1021 or whatever. I'm not sure what happened there. So as a possibility, I may allow you to use this other quiz instead. Okay, and that's probably what I'm going to decide to do. I just haven't made a final decision on that. Think of this like the election in America right now. We don't know what the outcome is. Okay, so but just in case I do decide to use that second quiz for you, go ahead and take it. By the way, if that is what I decide to do here, this will be the only time that I do things this way. From now on, if I set a deadline for 1020, what you really need to do is make sure that you submit it well before 1020, so that you make sure to get that quiz in time. Okay. So all right. So for going forward, make sure you do that. I think that's everything I wanted to cover as far as the quiz was concerned. And are we having some comments that I need to respond to in the middle of this? Let's see. Okay, this is all related to the example code that I showed. There we go. Yep. All right. So I can respond to some of. I'll respond to some of those during the break, during the 11:20 to 11:30 break. All right. All right. So let's go ahead and get into math characters if we don't have anything else. And let's see here. Let me share that. Okay. All right. So, so one of the things that we use computers, if you think about it, a computer, as we talked about in the very early lectures, we talked about that it's an adding machine. That really, the early computers that really, even the ones now that we're using, the thing that we're sitting on right now, all it's really doing is millions upon millions of calculations every second, and it's just doing addition, multiplication, division, all kinds of things. So one of the things that we want to be able to do as far as that is be able to have access to some quick mathematical functions that we don't have to rewrite them ourselves. Okay? And then the other part of this is characters and strings, and the reason why these are grouped together is because characters and strings is more about text, about how to deal with text, how to manipulate text and display it. These are put together into the same lecture because in Java, all three of these are done using classes. Specifically, one of the things that we're going to look at is some of the static methods and constants, particularly for the math class, and then also characters and strings, some of the static and non-static methods for things that we can do to manipulate strings and text. All right. Forgot this. One thing I wanted to start every class off with is my my quote of the day. So Grace Hopper was the developer of the first compiler. If you're interested, I suggest you look into her life. She was a rear admiral for the United States Navy many years ago. She was like it says there, developer of the first compiler. And actually, just entirely by coincidence, she happens to have the same first name as my daughter. So, but one of the things that I love about some of the quotes that I've included here is, again, this idea that we don't have to do things the way they've always been done, right? That, in fact, the first time that she tried to implement the first compiler, no one thought that computers can't run programs, is what many of the knowledgeable people, the people who knew what they were talking about, right, quote unquote, they would say, oh, computers can't run programs. Computers just do arithmetic. They just do adding and subtracting. That's all that they're there for. They're never going to be able to run programs, right? And yet, as we can see today, Grace was correct. And many of the knowledgeable people of the day were not. And the reason why, and it's not that those people were stupid or unintelligent. It's just that they were looking at what computers could do then. They weren't necessarily thinking about what they could do in the future. Okay, so just because something has always been done a certain way doesn't mean that we have to continue doing things that way. All right, so just a little encouragement for you that someday, who knows what someone in this class may invent or be a part of inventing, because just because you thought, you know, just because things have been done this way all my life doesn't mean it has to continue being done. All right. Now, speaking of that arithmetic stuff, computers do arithmetic, right? They are at their core adding machines, and so let's take a look at some of the useful methods and constants that us to in the math class. Okay. So the way that we access these, so pi, e, it would be some constants example. There are some class methods for like trigonometry, exponent, rounding. There is a random method inside of the math class that we can use. There's also a random class that we can use for generating random numbers as well. So Java gives a couple of ways to do that. Okay, so the way that we access these, I'm going to go ahead and just type that in here. Normally I would do this on the whiteboard, but we don't have one. So, okay, so these are what's called a static method, and what that means is you can access them without creating a class. You'll learn more about that in CSE 102. That's a little bit how static methods and non-static methods work, is a little bit beyond the scope of this class of 101. But just for your information, how you would do this is, so you type in the name of the class you want to use, and then you'll type in either if you're wanting to access the constant. So if when that happens, right, then what happens is the compiler takes that and replaces this with the value stored in that constant inside of that class. Okay. In the same way with a method, I wanted the max method like this. It takes that method, it calls that method, and it puts these two values into there. It passes these values to that method. Okay. So this is the way, it's just a class name dot method name and possibly any parameters, any arguments that may need to go there. Okay, so that's how we access that. You'll see that here in this example, right? So if we want some trigonometry going on with sine and cosine, stuff like that. Notice here, let me just point out this second example here. All right, so here, what happens is the compiler sees this and it replaces that with the constant value of pi that it uses. Okay, so it puts that in there and then it divides by 6, then it passes that value whatever it comes out with when it says what's pi divided by 6, it passes that value to the sign method inside of the math class. Okay. Same thing here where it divides by 2 and so forth with the cosines and stuff like that as well. Okay. So this is how we call the sine method. This is how we call the cosine method, and you can understand then how you would do that with the tangent and a cosine, a sine, a tangent as well. The arc cosine, arc sine, arc tangent. Okay, so that's how we call those methods. And notice that it returns a value. So the sine method is going to give me a value back. It doesn't display anything. You'll hear me say that quite a few times during the next couple of months as we end into next year, if you take me with 102 as well, is one of the biggest confusions, one of the biggest, one of the most common confusions I see amongst early programmers is when a method returns something versus when it displays something. So a method returns a value means it just replaces the when this line is executed, it's like this whole thing just gets replaced with the value 0.5. Okay. Whereas displays something would be if it gets displayed to the screen. It doesn't necessarily return anything, but it displays that to the screen. Okay. So in order for me to see this value, I would have to have like a system.out.print or print line or something like that in order to make this be displayed to the screen. Without a system.out.print or print line, nothing gets displayed to the screen if we see this. Okay, if we have this kind of line here. Okay. Some other examples: exponents, logs. I'm really not going to go. I'm going to go quickly through these slides a little bit because I really feel that showing examples is the best way to learn some of this, and actually sitting down and typing code, running code is the best way to learn some of these things. Okay, so for here, just some exponent, log, PAL raises the first value to the second value. Notice that it's two doubles, so it's a double A, double B, so it's a double parameter, which means even if we pass it this 3, which is an integer, 2, which is an integer, those will get put into double variables inside of the method, and it will return a double value. Okay. Here, notice we can pass it two double parameters. Square root, the same way, takes a double parameter, and it returns a double value. Okay. We also got some rounding methods. So ceil, this CEIL is short for ceiling. It means it's rounding up to the nearest integer value. Now, it is returned as a double value, so it does return a double value, not an integer, but it's the up nearest 0.0. Okay, so if I pass it 3.5, for example, it will return 4.0. If I pass it 3.1, it will return 4.0. If I pass it 3.0000001, it will return 4.0. Okay, it's always going to round up to the next the next integer value. Okay, so even though this is much closer to 3 than it is to 4, because it is above 3, it will go up to 4.0. Okay. All right. Floor is just the opposite. It rounds down. So 3.5 becomes 3. 3.9 becomes 3, also 3.0. Not 3, 3.0. Let me make sure I make that clear. 3.99999 gives me 3.0. Okay, so So it always rounds down, no matter what, no matter how close to the upper value it is, it's always going to round down. Okay. All right. Now x is rounded to the nearest integer with r int, round int. So if it's equally close to the integers, the even one is returned. So basically 3.5 becomes 4.0. 3.45 becomes 3.0. 3.55 goes up to 4.0. Okay. Now remember, this doesn't change the value of the parameter being passed. This just returns a value based on the parameter. So x stays the same value as it was before. It just gives the result of, if I were to round this, what is that value? Okay. All right. Round int, giving a floating point value, will also round down for anything below 0.5 and round up for anything above 0.5, for anything 0.5 and up, rather. Okay. See why that is based on why we use the floor method and how this ends up working out the way it does. Okay. All right. Let's take a look at some others. So this is some examples. Go through those. I've given some on the previous slide by typing them in, but they won't stay there because when I close this file out, I won't save the changes, and so you'll need to keep note of these so that you know how the seal, floor, round methods work. All right. Max, min. All right. Takes two values, gives me the maximum of the two. Min gives me the minimum of the two. Pretty self-explanatory. Okay. Absolute value returns the absolute value. So basically, if it's a negative number, it returns a positive. If it is a positive number, it returns the same number. Okay. It's a double, right? I think it might be overloaded, which is another CSE 102 term, but I think if you pass it an integer, it gives you an integer back, and if you pass it a double, it gives you the double back. I think is the way that shows up over here. Okay. Random. Let's talk a little bit more in depth about the random method. So it returns a random double value between 0.0 and 1.0, including 0.0, but not including 1.0. So basically, the highest value that you could get back would be, like 0.9999999 something, but never exactly 1. You'll never get exactly 1 from the random method itself. Okay. So this is how we're going to use the random method a lot of times, is because usually we don't want some random value between 0 and 1. What we want is a random value between 1 and 6, including 6. That would represent a dice roll, right? So I'm sure many of you at some point in your life have played Tavla, right? And so, how do you determine how to move the pieces? Well, you roll the 2 dice, right? And you get, one of them gets a number between 1 and 6, the other one gets a number between 1 and 6, and you decide how you're going to move your pieces based on those 2 numbers, right? Well, a computer doesn't have access to physical dice to roll, right? And so it needs to have some way to be able to generate those 2 random numbers between 1 and 6. So you would use some formula like this. So notice here, if we say, give me a random number between 0 and 1, a double random number between 0 and 1, and what's going to happen? If I multiply by 10, that means I'm going to have some random number between 0 and 10, but including 0, but does not include 10 itself, right? So then if I convert to an int, if I say cast that to an int, what happens to the stuff after the decimal? All right. What happens to the stuff after the decimal? It just goes away. So now I have a number over here, just, oh, I tried to cover up part of the slide with my hand as if you could see it. Anyway, if all you had was, show this, if all I had was this part before the casting to the int, remember I've got a random number between 0.0 and 9.99999. Okay, it's somewhere in that range. Now when I cast that to an int, it's going, anything between 0 and 0.99999 becomes 0. Anything between 1.0 and 1.9999 becomes 1, and so forth, all the way up to 9 point something becomes 9. So now I have this formula will give me a random number between 0 and 9. Now, if I wanted to make that a random number between 1 and 10, what would I do? Well, I already have this formula that's going to give me a random number between 0 and 9. If I just take whatever I get and add 1 to it, so 1 plus whatever this is, then I will have a random number between 1 and 10. Okay, so here if I wanted a random number between 50 and 99, I could just add 50 to a random number between 50 and 99. All right, so this will give me a random number between 0 and 49. This will add 50 to it to give me a random number between 50 and 50 plus 49, which is 99. Okay, so a general formula for this, A plus this math.random times B to give me a number between A and whatever A plus B is, excluding A plus B. Okay, make sure you remember this. Okay, remember this formula. This is a way that we can take that to generate random numbers. One of the most useful tools in computer and software development is being able to generate random numbers. If you've ever lost your password to something, to an account, to your, to some account of your, where you know your username but you forgot your password, and you click on I forgot my password, and they send you a temporary password made up of a random set of characters. They used some type of random feature to generate those characters. Okay, if you've ever played a game, a video game, it most likely used some type of random method in order to, if you played Tavla on the computer or anything involving dice on the computer, it creates a random number generator for the dice. If you've ever played OK, I know these are both Turkish games that I've seen a lot of people play. If you've ever played OK on your phone or on a computer, it randomly decides how to stack those tile pieces, right? If you've ever played a card game on a computer, if you ever played poker, or there's a Turkish card game, I can't remember what it is, but I've never played it. Anything like that where there needs to be a shuffling of the cards, there's a random generator that will do that. Okay, it's the fun of the game, right? No game is fun if it's completely decided from the beginning, right? No one likes to play games like that. We like to play games where there's some randomness in it, and this is how a computer will do it. Okay. One thing to let you know about randomness, though, technically there is no such thing as a truly random event in a computer. That even this random number is something that's based on a, depending on the language, whether it's Java, C, or others, is this predetermined ordering of numbers that's stored in like a table. And the way it decides which number to choose is based on the computer system clock. So the only way that you could guarantee that two computers would produce the same result when using a random number generator would be they would have to have the exact same system clock, and the programs would both have to be started at the exact same moment down to like the millisecond. So technically, not truly random, but at the same time, it's not really possible to make them not random. Okay, all right. So we can look at the case study, but I'll probably skip this one. I probably won't show this as an example. All right. But that ends our discussion on the math class. I do want to go ahead and cover the character class before we take a break because I don't want to because I want to save the string class for the more in-depth discussion. We may take our break a bit early today. All right. Now, characters and how text is done in Java, in computers, in most programming languages. So they are actually represented by numbers, by number values, okay? The reason why this is important is that the character A, for example, has a numeric value. It's actually this 41 in hexadecimal. So this isn't decimal, this is actually 65 in decimal, okay? But it's represented using hexadecimal digits. You'll learn more about hexadecimal in another class. This is beyond the scope of ours. But just to let you know that this character, anytime you see text on a screen or in a computer program or saved in a file, it's stored as a sequence of zeros and ones that it has a numeric value. Okay, so we can actually take something like this, add something to it, and it will display that next character up. So the character lowercase a, which is 65 plus 32 is 97, is 97 in decimal. All right. We add one to it, we'll get 98, and we'll actually display the result of a character at 98, which would be the character B. Okay. I don't think I have an ASCII table. I do actually down here. Okay. Skip over the Unicode format. I don't know. You don't know that. Okay. So I am not expecting you in this class. This is not to say that you won't one day in a later class be expected to have all these things memorized. I'm not expecting you to memorize what values are for characters 0 through 9, what values are characters A to Z and or Z if you're British, or character lowercase a to lowercase z. All right, I don't want you to know these specific values. If you do, that's great. It'll help you. But I'm not expecting you to memorize these values. What I do want you to know, what I do want you to remember is that the numbers, the digits in characters is the least of these in terms of the value. So 48 is less than 65. I hope that is not a shock to you. All right. So the digits are the least of these. The capital letters come next. The lowercase letters are the greatest. And that's important because when we compare strings, when we'll get into strings in a moment, when we compare strings to see which one's greater or which one's less, when we compare characters to see which one's greater, which one's less, it's using these values here, the numerical values, to help us understand how to compare them. So what that means is, let me insert a text box so you can. There's my text box. There we go. So what that means is that if I had a character E, for example, and I were to say, is that less than, greater than, or equal to, I'll say lowercase a, So what do you think? Do you think an uppercase G is less than, greater than, or equal to a lowercase a? Right, good. Glad to see all of you answering correctly there. Right, because G is somewhere in this range of 65 to 90. Even if you don't know the exact value, which it would be whatever, 65, I don't know, 70, I don't know. I don't remember. See, I don't even remember. I don't have all this stuff memorized. All right, so, but it's somewhere in the 65 to 90 range. Lowercase a is 97. And even if it was any other lowercase letter, B, C, D, whatever, it's going to be somewhere in this 97 to 122 range. And so therefore, no matter what, all uppercase letters will be seen as less than all lowercase letters. Okay? The reason why this becomes important is because, like I said, when we start comparing strings to each other, this is the example I use all the time, every year. Many of you who have had me before, you recognize this. You've seen this example used a lot. Okay. So the question becomes, okay, is Star Trek less than, greater than, or equal to Star Wars? Right. And just like with the G compared to the lowercase a, is Star Trek is less than Star Wars. Star Wars is greater. Okay, so we've settled the debate. Star Wars is greater than Star Trek. All right, no more having to argue about this. Okay, now the reason for that, here's how when we compare two strings to each other, we go to the first character of each one. Oh, they're the same. We go to the second character, they're the same. We go to the third, the fourth, the fifth, the sixth. We keep doing it as long as they're the same value, we go to the next one. So it's kind of like in the dictionary, right? You compare character to character until you finally get to something that doesn't match. So here we have a T and here we have a W. So which one is less than the other? Well, that's where now both of them are capital letters, right? Both of them are capital letters. So that means they're both in this range. So now it becomes which one comes basically earlier in the alphabet compared to the other. So T comes before W, which means that Star Trek would be seen as less than Star Wars. Okay? Now, could I make Star Trek greater than Star Wars? Sure. You know how to do that? Make that a lowercase t. Now, a lowercase t means that this, now when we compare this t with this w, what happens? This t is now up here in this upper range. So it becomes greater than Star Wars. So for all you Star Trek fans out there, there is a way to make Star Trek greater than Star Wars. Okay, so you can do it. All right. Moving on. I hope that's clear. Again, one thing I want to make very, very, very clear is I'm not expecting you to memorize all these values. Like I'm not going to ask you on a quiz or on an exam. I'm not going to ask you what is the ASCII value of a lowercase q. Okay, that's not going to be a question that I'm going to ask. What I might ask you though is which of these two strings is greater than the other? And I will want you to be able to say, oh, STAR space. By the way, space is there. Space is a character. Okay? It does have an ASCII value, so it does count as a number of characters. Okay. Space is space. T and W, okay, that's where I need to, which one of those is greater than the other? And that's what I will want you to be able to tell me. Okay. All right. Some example of some escape characters, what we call escape characters. So the main ones you'll need to know here will be the T, the N, the slash, and the quote. Okay, so these two and then these two. I will want you to know those. So basically what happens is sometimes we want to be able to print characters that have special functions, or we might want to print white space characters in order to do things. So for example, the new line, okay? So this N is a new line. Now, the reason why we have to have this slash is because what would normally happen if I did what would normally happen is when it got to this N here, is it would just print an N to the screen, right? So if I put an N on the end here, it would just print this string out, right? But what if I wanted there to be a new line after this? After this, I wanted there to be a new line. This is another. Now what I can do is I can put a slash in there. Now what the compiler does when it sees this, what the compiler executor does when it sees this is it says, okay, this slash means escape the next character. It means whatever the next character is, don't do what I would normally do with that. So when normally I would just print an N, but instead of doing what I normally would do, I'm going to do whatever this specific thing is supposed to do. So the specific thing is N, which means new line, which means I'm going to put a new line into here and I'm going to bring the output down to the next line. Okay. In the same way, T, normally I would print the T. So what am I going to do instead? I'm going to tab over. I'm going to add some spaces. So if I were to do slash T, then it would move over some spaces. Okay. Some other examples here, the backslash slash, backslash backslash. Remember, what would normally happen when it encounters a backslash is it would escape the next character. It would do something special with the next character. So what this first backslash is saying is, okay, don't do what you would normally do with the next character. Well, what's the next character? It's a backslash. Normally, what I would do is escape the next character, but I'm not going to do that. So instead, I'm going to put a backslash into my string. Okay. Here, what would I normally do with a double quote? I would end my string. My string would be over. So what am I going to do instead? I'm going to print or display or add to the string a double quote character. Okay. I hope that's clear. We'll see some examples. It may be clearer once we actually do some examples in there. Okay. So if you want to see the ASCII character set, for the full lower level set of ASCII characters, this would be it. This is all of your numbers, your uppercase letters, your lowercase letters, some special symbols, stuff like that. Space, I believe, is 20 or 30, 32. All right, so 32 is a space character. Okay, and then there's some others as well in the hexadecimal format. So yeah, 20 is a space. Okay. Again, this is just here for you if you're interested. It's not something that I want you to memorize in any way. Okay. So if we were to say, I want to store the value of a character into an integer variable, I can do that. Okay. Remember, the character variable, the char. Sometimes you hear it referred to as char, sometimes you'll hear it referred to as char. It is a numeric format. It is an integer format variable because it is stored as an integer. Instead of ones and zeros, it's stored as an integer that has the ASCII value of whatever character it is that it represents. Okay. So, but we can cast between the two types automatically. So here is an example. If we compare, we can compare, say, oh, if it's somewhere in this range, print that it's an uppercase letter. If it's somewhere in this range, print that it's a lowercase letter. If it's somewhere in this range, print that it's a numeric character. Okay. So the way that we would do this in the character class is we say, you know, character. Let me insert, try to show you some examples here. Dot is digit, and then we pass it some character value. It could be a variable, it could be a value. So I could do a single quote, a single quote for character because a character is a single quote. A double quote will be seen as a string, even if it is only one character long. A double quote will say that's a string and not a character, so it'll mess up. Okay, it'll probably give you a compiler error. So this would not give me an error because isDigit just is a Boolean method that tells me whether or not what's inside is a digit or not. Okay, so this would return false because S is not a digit. This would return true because 3 is a digit. Okay. Same thing with letter or digit, is it returns true if it's a letter, uppercase or lowercase. Is letter or digit returns true if either of those two is true. Is lowercase returns true if it's a lowercase letter. True if the uppercase is uppercase, returns true if it's an uppercase letter. And then we can cast them to lowercase, to uppercase. Think of this as similar to the absolute value method, okay? Where the ABS, where if I pass two lowercase, if I pass it a lowercase letter, it just returns the same letter. If I pass it an uppercase letter, it returns the lowercase version of that letter. If I pass it a number, what do you think happens? You know what? I think that's a good thought question. We've hit our break time. What do you think would happen if I pass two lowercase or two uppercase, a number, or anything that's not a letter? And what do you think would happen if I did that? Remember, this doesn't change. So like isDigit, two lowercase does not change the value of the variable that I'm passing. It returns the result of operating on that variable. Okay, so if I pass it a lowercase, if I pass two uppercase, a lowercase a, for example, it returns an uppercase a, but it leaves the variable the same, a lowercase a. Okay. All right. So we'll move on to string after the break. But during the break, what I want you to do is I want you to tell me, what do you think would happen if I pass two lowercase or two uppercase methods? Instead of passing them a letter, I passed them a digit, like a number, like so I did like this. And no cheating by doing this in Java, like pulling up a Java program and running this, okay? So if I did this, what would happen? Would it give me an error? Would it give me something else? What would happen? Okay? All right, so think about that over the next 10 minutes. I'll see you at 11:30.